This is Grade 6 Math, Chapter 3.4, Part 2, More Real-World Problems with Fractions and Decimals. Let's keep going. In yesterday's lesson, we learned to both multiply and divide by decimals, as well as to multiply and divide by fractions to solve two-step word problems. Today we'll begin by deciding whether rounding can help us solve real-world problems. Let's begin with a word problem. Kathy has 9 sticks of modeling clay. She cuts the pieces into thirds and then shares those pieces equally with some children. Each child gets 2/3 of a stick. If we know that each child gets 2/3 of a stick of clay, how many children are there altogether? Our first step in solving this problem is to create a division statement. If we have 9 sticks of modeling clay that we're dividing into 2/3 segments, we need to know how many times 2/3 fits into 9. So let's go ahead and solve this problem. 9 divided by 2/3 is the same as 9 times 3/2. When we compute this through, we get an answer of 27/2, which when converted to a mixed number gives us 13.5. So our answer is telling us that we have 13.5 children. I'm guessing you can immediately see the problem with this answer. It's a little tricky to have a half of a child. So at this point, we need to make a decision. We need to round up or round down to decide how many children there were altogether. Well, if we have enough clay to give 2/3 a stick to 13.5 children, we'd better say we're going to go with 13, right? Otherwise, somebody's going to be shorted and they're not going to be happy. So what fraction of a stick of clay is left if we give away 2/3 sticks to 13 children? We'll solve this step using multiplication. If we give 2/3 of a stick to 13 children, we've given away, let's see, 26 divided by 3, or 8 2/3 sticks of clay. So what fraction of a stick of clay is left? Well, 9 minus 8 2/3 gives us 1/3 remaining. So we have 1/3 of a stick of clay left. So if we wanted to give away this remaining 1/3 stick of clay, what is the total amount of modeling clay each child would get if the remainder was divided evenly and added to the clay that they already had? There are 2 different ways we can approach this problem. In method 1, we'll take our remaining 1/3 stick and divide it by 13 so that we can create 13 equal shares. This becomes 1/3 times 1/13, meaning that each child receives an extra 1/39 of a stick of clay. So we add that to the 2/3 that the child is already getting. 2/3 plus 1/39. If we create equivalent fractions here, that will give us, let's see, 26/39 plus 1/39. So each child would get 27/39 sticks of clay. I think we can reduce this. Each of those is divisible by 3, right? Yeah, I think so. That would give us 9/13. So each child would receive 9/13 of a stick of clay in total. All right, there is another way that we can do this problem as well. Let me show you method 2. Method 2 gets directly to the point. We have 9 sticks of clay that we're going to give to 13 children. What is 9 divided by 13? Well, it's 9/13. So each child gets 9/13 of a stick of clay. A lot simpler, isn't it? Now try one of these problems on your own. This particular setup walks you through all of the steps, but I'll talk you through it as well. Meredith bakes 5 pumpkin pies. She cuts the pies into quarters and distributes the pieces equally amongst her neighbors. Each neighbor receives 3/4 of a pie. Yum. How many neighbors does Meredith distribute pies to? Press pause, go ahead and figure out how many neighbors will receive pies. When you're ready to move on, press play again. Remember, it would be pretty weird if Meredith had partial neighbors, so don't forget to round up or down to figure out the correct answer. After Meredith has given away 3/4 of a pie to each of her neighbors, what fraction of a pie is left? And then, once you figured that out, calculate what is the total amount of pie each neighbor will receive if the remainder is divided evenly and distributed to each neighbor. This problem works exactly like the clay sticks problem we worked through together. If you're confused, go back and watch that one again. It will really help you process the steps for this particular problem. Press pause, complete your work, and when you come back, we'll do another sample together. Now give this problem a try. Some bottles containing 2/5 gallon of water each are used to fill a 7-gallon container. How many of these bottles are needed to fill the container with water to its brim? Don't forget to round. If you use a partial bottle, it still counts as a whole bottle in our count. For example, if you need at least 10 bottles and you open an 11th, that 11th bottle still counts. So your answer would be 11. In this example, you'll be rounding up, more than likely, instead of down, as you did before. Press pause while you work, and when you come back, we'll divide fractions by whole numbers. Now let's work through an example where we'll divide a fraction by a whole number to solve a real-world problem. Lucille collects U.S. stamps and foreign stamps. 1/4 of her stamps are foreign stamps. She divides the U.S. stamps equally between two friends, Michelle and Nadia. Another way to say that would be that Lucille gives 1/2 of 3/4 to each Michelle and Nadia. If Lucille has 72 stamps total, 72 foreign and U.S. stamps total, how many stamps does Nadia receive from Lucille? There are two different ways we can solve this problem. Let's first use the method that asks us to draw a bar model. In method 1, we begin with a bar that represents the total number of stamps. We know that Nadia has 72 stamps total, and that 1/4 of them are foreign stamps. The rest are U.S. stamps. The next piece of information we have is that Lucille is going to give 1/2 of her U.S. stamps each to Michelle and to Nadia. So if we want to divide our 3/4 into 2 equal parts, we'll first divide each of these segments in half to give us 6 segments. We'll also need to divide the foreign stamps in half just to keep this equal. Now we can divide our 3/4 in half equally. Michelle will receive 3, and Nadia will receive 3. So now our model shows us that Nadia receives 3, 1, 2, 3, of the 8 segments. So she gets 3/8 of the total number of stamps. The question, however, is how many stamps does Nadia receive? Not what fraction, but what actual number of stamps. So we know that of the 8 units of stamps represent 72 stamps total. So 1 unit of stamps will equal 9 stamps. So if Nadia receives 3/8 of our stamps, that means she gets 3 units. So 3 times 9 is 27. Nadia gets 27 stamps from her friend Lucille. Now let's work through method 2. From our group of stamps, represented by 1, our whole, we need to subtract 1/4, which is our foreign stamps, to see that we have 3/4 of our total as U.S. stamps. Lucille's going to take that 3/4 of her stamp collection and divide it equally amongst 2 friends. So we're simply going to take 3/4 and divide it by 2. We know how to do this, right? And then working this through, we get 3/8 of the collection going to either Nadia or Michelle. If our total number of stamps is 72, we can now take this 3/8 times our total number, 72, and that should tell us how many stamps that Nadia or Michelle receives. 3/8 times 72 gives us 27, because we can cross reduce this to be 1 and 9, simplifying the problem to 3 times 9. And we can see now that Nadia receives 27 stamps. Both techniques are equally valid. Use whichever one works best for your brain. Personally, I prefer the mathematical technique, but if you like to see the picture, please go ahead and do it that way. Give one of these problems a try on your own. This example will walk you through method 1. Lillian has a part-time job. Each month, she spends 1/3 of her earnings on clothes, saves 3/8 of the remainder, and spends the rest of her earnings on food. So you need to calculate what fraction of her earnings does she spend on food, and if she earns $540, how much does she spend on food each month? The models for method 1 are drawn for you here to show you what she spends on clothes plus her remainder, then how to divide that into saved and food in equal units. Go ahead and calculate the answer from here. Press pause, and when you get back, I'll get you started with method 2. Now that you've finished using the bar model, try using the purely mathematical method. This example walks you through what to do so that you can calculate it. Press pause and give it a try. And now we've arrived at our final idea for this chapter, dividing a fraction by a fraction to solve a word problem. Stephen uses 2/3 of his garden to plant tomatoes, and another 1/9 of it to plant lettuce. He then divides the rest of his garden into several small plots of land. The area of each small plot of land is 1/18 of the area of his entire garden. So how many small plots of land are there? First, let's find the fraction of Stephen's land that he divides into small plots. So the fraction of land that he's divided is 1, the whole, minus the fraction that he uses for lettuce, which is 1/9, and the fraction that he uses for tomatoes, which is 2/3. So that tells us we need to subtract 7/9 from 1. So 2/9 of the garden is divided into these small plots of land. Now we'll solve to find out how many 1/18 are in that 2/9. So we'll take 2/9 and divide it by 1/18, or 2/9 times 18 over 1, which will give us, let's see if we cross divide here, we have 1 and 2, so we have 4. There are 4 small plots of land. If the total area of Stephen's garden is 90 square yards, what is the area of each small plot of land? So our question here is, what is 1/18 of 90? Remember, of is code for multiplication. So what is 1/18 of 90? It's 5. So each small plot of land is 5 square yards. Let's try a couple of these problems on your own to close out chapter 3.4. 2/3 of a square is colored green. Asha cuts this green part into a number of pieces so that each piece is 1/9 of the whole square. In problem A, you're asked to find the number of pieces that Asha has. And in part B, you're asked to find the area of each piece if we know that the area of the square is 45 square inches. Use the steps that are laid out for you. They'll be really helpful. Press pause and then come back for one final practice problem. All right, folks, here's your final problem for this chapter. 3/5 of the students in the class were boys. The teacher divided the boys equally into groups so that each group of boys had 1/10 of the number of students in the class. The teacher then divided the girls equally into groups such that each group of girls had 1/5 of the number of students in the class. In question A, you're asked to find the number of groups of boys and the number of groups of girls. Once again, follow the path that the book has laid out for you here. It'll really help to clarify and to see what numbers you should be working with. In part B, you're asked if there were 16 girls in the class, how many boys were there in each group? Once again, follow what is laid out for you here. It will really help to make clear which numbers you should be using. Regardless, we'll go over these together tomorrow to make sure you understand. So finish up, enjoy the rest of your evening, and I'll see you tomorrow to work on more word problems together.